Hello students, your teacher here, Mr. Sarasinski, with another episode of Algebra 1, Lesson 5.1, Solving Systems of Equations by Graphing. Boom shakalaka. Here we go. So what is the systems of equations? Well, double plural there sounds kind of strange, but a system is two or more equations with the same variables. Okay. Graphically, the solution to a system of equations, okay, so we're talking about two, in this case, two lines, two linear equations, is the point at where the two lines intersect. But this also applies to even higher level equations like systems, quadratic systems, cubic systems. It's the solution is where the lines intersect. All right, and then algebraically, it's the point that makes both equations true. All right, so what do intersecting lines look like? Well, anytime you have two lines and they cross each other, this is the point of intersection. That would be the solution. And the solution would be in the form of an ordered pair, x comma y. If you have parallel lines, so we have a system and we graph them and they're parallel to each other, well, these never cross, they never intersect, and so there's no solution. And then we have a scenario where we have a line, and then we have another line right over top of it, okay? This is infinite solutions. All right, so how do we solve systems by graphing? Well, first thing we need to do is we need to rewrite the equations in slope-intercept form. And this, of course, is only if they're not in slope-intercept form. Step 2, graph the line. So if we've got them in slope-intercept form, remember, you plot the y-intercept, and then you use the slope to find your next point. And then 3, identify the solutions. All right, this is the part where you say, do they intersect? If they do, what are the coordinates for that point? Okay, so number 1, I'm going to graph each of these. So I'm going to graph them in different colors. So we're going to start out with red. And y equals x minus 8. So negative 8 is where my y-intercept is. And then my slope, because there's nothing in front of x, it's just 1. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So this line, and I want to make it pretty long because I have no idea where they're going to intersect yet. Okay. And my second line, blue. So my second line has a y-intercept at 1. Whoops. Y-intercept at 1, and the slope is down 2, right 1. It's negative 2 over 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. Okay. So the point of intersection is right here. What are the coordinates for that point? Well, let's see. 1, 2, 3. Negative 1, 2, 3, 4, 5. So 3, negative 5 is the solution to that system of equations. Number 2, y equals 1/2 x plus 9. Well, the y-intercept is there at 9, and then slope is up 1 over 2, down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. Okay. All right, there's my first line. In the second line, the y-intercept is at 6. and the slope is -1. Okay, since there's nothing in front of the x except for a minus sign, then the slope is -1 over 1. So we go down 1, right 1, or up 1, left 1, up 1, left 1. Okay. All right, so we can clearly see that these do intersect, so they have a solution. And the solution is at 8, or -2, 8. All right. Moving on. See, this isn't too hard. All right, number 3. You knew it was coming. Both of these are in standard form, so we got to convert to slope-intercept. Subtract 3 or add 3x to both sides. Y equals 3x plus 8. That wasn't too hard. And then add x to both sides. Y equals x minus 2. All right. We've got them written in slope-intercept form. Let's graph them. First is y-intercept at 8. And the slope is 3. But what happens when I go up 3 and over 1, I go off the graph. So I need to go down 3, 1, 2, 3, left 1. And then down 3, left 1 from that point. Then down 3, left 1 from that point. Okay, so that should be enough. Go ahead and connect these. All right. Now I'm going to graph my other line. Y equals x minus 2. So the y-intercept is at -2, and the slope is up 1 over 1, up 1 over 1. Down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. And it looks like they intersect right there, which is the point -1, 2, 3, 4, 5, and then counting down 1, 2, 3, 4, 5, 6, 7. All right, number 4. Well, we got one equation in slope-intercept form, but the first one we need to convert. 2y equals 4. Subtract x from both sides. 2y equals -x plus 4. Divide by 2. Y equals -1/2 x plus 2. All right, so let's graph the first equation, -1/2 x plus 2. So the y-intercept is at 2. Oops, using the wrong color. Then I go down 1, right 2. Down 1, right 2. Up 1, left 2. Up 1, left 2. And I'm going to go ahead and make a line. All right, and then my other equation has a y-intercept at 2, and the slope is down 1, left 2. Down 1, right 2. Down 1, right 2. Uh-oh. These are overlapping lines. What is the solution when we have overlapping lines? Well, they touch in an infinite number of places. So if the solution to a system of equations is where they intersect, well, this is intersecting at an infinite number of points. So the solution is infinity. All right, number 5. We got one solved, but we need to get this other one in slope-intercept form, okay? So I'm going to subtract x. We get 3y equals -x minus 15. Divide by 3. Y equals -1/3 x minus 5. All right, so the y-intercept is at -5. Okay, and we're going to go down 1, right 3. Down 1, right 3. Down 1, right 3. Okay, up 1, left 3. Up 1, left 3. Up 1, left 3. All right, there's my line. Connect the dots. All right. And then the line y equals -7 is a horizontal line where, let's see, 1, 2, 3, 4, 5, 6, 7. It's a horizontal line right there. And you can see right here is where they intersect. That is the point 2, 3, 4, 5, 6, -7. Okay, number 6. Let's convert x minus y equals 2 to slope-intercept form. Subtract x, negative y equals -x plus 2. Divide by -1 because we can't leave y as a negative. Negative x divided by -1 is positive x, or positive 1x. Positive 2 divided by -1 is -2. So let's graph both of these. The first equation, y equals x plus 5. Y-intercept at 5. And then since the slope is 1, we go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. And then we connect the dots. Okay. All right. And then the second equation, the slope is y equals, or the y-intercept is at -2. And the slope is also 1. So up 1 over 1, 1 over 1, up 1 over 1, up 1 over 1, 1 over 1, up 1 over 1. All right, but what I want you to notice is they have the same slope, but different y-intercepts. In this case, we have two parallel lines, so there are no solutions. Number 7. All right, got to convert both of these. 3x minus 5y equals -35. Subtract 3x from both sides. -5y equals -3x minus 35. Okay. And then divide by -5, and y equals positive 3/5 x plus 7. So negative divided by negative is a positive. And then let's convert the other. 2x plus y equals -6. Subtract 2x, and you get y equals -2x minus 6. Okay. Let's graph the first equation. Y-intercept is at 7. And then we go up 3 over 5. Up 3 over 1, 2, 3, 4, 5. And we go down 3, left 5. Down 3, left 1, 2, 3, 4, 5. And let's make one more. Down 1, 2, 3. And it'll be right there. Okay. Connect the dots. Easier said than done. All right. Now the second equation. Y equals -2x. The y-intercept is at -6. And then the slope is down 2, right 1. And up 2, left 1. 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 All right, so these intersect at that point. And where is that? That is -5, +4. Okay. And last but not least, we only have to convert one equation here.